All right, so can you guys see my screen?
Yes, sir.
Yes, sir.
Yes, sir.
So we are already done with the week 1 and week 2. So for the week 3, so there's actually only one, which is the schematic diagram. But if you're going to take a look on this one, week 3 and week 4 are like uh, connected with each other, wherein you're going to, well, either of those two. So you can draw a sketch first, and then you can have your own real schematic diagram on the software, let's say using Fritzing or using an Eagle guide. Okay, so the one that we're going to discuss for today is mainly schematic diagram. Okay, and then for the finals, we'll start with introduction, of course, of the Eagle guide. All right. So the remaining meetings that we'll be having next meeting will be your free time to explore the Fritzing, install the Eagle guide, and of course, review your week 1 and week 2 and week 3 modules, and of course to finish all of your laboratories. Okay, so yeah, that's it. And as you guys can see, week 5 is only like introduction, right? But since we don't have week 6 anymore, which is for the real project, we don't have PCB fabrication, we don't have component soldering, we don't have matrix board, we don't have etching. So we only have one last topic for the finals. Okay, but even though we only have one topic, okay, so mastering EagleCAD is not that easy. So I'm telling you guys, especially if it's your first time, you'll get frustrated. So in our case before, I even uh, having a hard time in, let's say, routing 6 components, let's say 3 resistors, 1 capacitor, let's say 1 inductor, and then 1 voltage source, and then let's say another LED. Okay, let's say having those components as 7 or 8, that's already a complicated circuit. Okay, so it's not that easy, especially if you're going to route it on a very small PCB. Okay, so as early as of now, let's say the remaining time that you have, I would like you guys to have an advanced study about EagleCAD. All right, so learn about EagleCAD, how to install it, how does it work, where are your components, how do you go with the routing point or the schematic part, etc., etc. Okay, so yeah, and for the week 3, module 4, which is a schematic diagram. So here's the overview. Oh, this one is very straightforward. So we only have 2 topic learning outcomes. So of course, we'll define how to read schematic symbols and diagrams. But when it comes to reading schematic, that actually depends on the circuit or the components that you have on your project. So I will just introduce to you the symbols and then some of the components. Okay, when it comes to reading such thing, so it is now depending on the circuit that you have on your simple project. Okay, and for the second one, so differentiation of normally open and normally closed switch. Okay, and then here are the list of topics, and then we have here the learning resources. Of course, we have here the PDF of your module 4. So just download that one if ever you haven't downloaded the module 4 yet. And then I have prepared 3 video materials here, wherein it will talk about here how does normally open and normally closed switches work, and then how to read the schematic and the principles of schematics. Okay, and then there is one reading materials here wherein it talks about circuit symbols, okay, or how to create or how to start on creating a schematic diagram. Okay, and for the references, so this one is actually the same with the circuit symbols. So most of my presentation came from this website. All right, and so yeah, that's for the overview. And here's the PDF, so just download this one now. And I have prepared 2 practice exercises. Well, the other one is just like a cheat code. like it's being black. And the other one is a quiz, a short quiz. It's being black again, the canvas. Okay, so this one is like the overview on how to read a schematic. Okay, so you have the logic gates, integrated circuits, you have BJTs, voltage sources, so DC, AC, and batteries, and so on and so forth. Okay, so this is where you will learn more in the basic when it comes to creating a simple project. Okay, so of course resistors, you'll be needing this one in whatever project you're going to create, and variable resistors. Like this is the potentiometer. If you want to control, let's say, a certain amount of current or a certain amount of voltage. And we have here the capacitor. So we have discussed this one last meeting already, which is non-polarized and then polarized. So both of them work the same. It's just that the other one is much more expensive. Okay, the non-polarized. Polarized is much more cheaper, but you have to follow the correct polarity. And then inductors, switches, dip switch, and sources, DC, AC, for the batteries, for schematic symbols. So you guys already know this one. So these are the basics for the VCC and the ground. So we have many kinds of the symbols for ground. And then we have here diodes. So for diodes, you guys probably already know this one since you guys are already done with electronics. Okay, fundamentals of electronics. And we have here LEDs, photodiode, SCATI diode, Zener diode, NPN junction, PNP junction, and many more. Okay, so as you can see, this is like a very complete sheet code for the starter. Okay, when it comes to creating a certain project. Okay, and then here are some of the basic schematic diagram. So we have here the battery, the resistor, the LED, and many more. Okay, and then we have here some ICs where it has a connection to your other ICs. Okay, and some complicated ICs. Okay, like for example, this one, you have this complicated wirings. So routing this one, without crossing other wires to let's say a PCB or schematic diagram is the difficult part. So putting a lot of components or making your schematic diagram on, say, Fritzly or EagleCAD is easy. However, when it comes to real uh, route of your wirings, that's where the difficult part is coming from. All right, and many more. All right, so make sure to check this website. And then the other one is just a quiz. Okay, so in here you're going to answer this one, etc., etc. Okay, and yeah, so just do check this one, just to exercise your brain when it comes to schematic or circuit diagrams. And for your lab number 6, so later on we'll discuss about that. But for now, let's now move on with your module 4 schematic diagram. All right. So, any questions so far before we start with our module 4?
I'm good, sir.
Answer.
None so far, sir.
Not so far, sir.
How about in our past modules and laboratories? Any questions or clarifications so far regarding with those? So let's
None,
have this time as your consultation time at the same time. Okay, so if you guys do not really have a question, so feel free to ask me anytime in the future, maybe tomorrow, maybe next week, if ever you've encountered a problem or a question.
Yung
Alright.
lab 5, sir, kahit super simple lang, okay lang?
Yeah, kahit sobrang simple. Actually, you can just have one resistor and then one LED. And that's it. I just would like you guys to explore the fritzing. So that's the reason why. Okay. And then of course you have to level up yourself. Okay. Starting, with 2 components, why not create with 4 components, 5 components, and so on and so forth. All right.
Sir, paano po malalaman kung tama yung connections mo dun sa my fritzing?
Oo,
We
kasi
have
walang simulation.
So, if you're going to take a look on this one, can I just recycle previous projects? Yeah, you can recycle previous projects, so no problem with that. As long as you're the one who's going to create it on the Fritzing, okay? You do not just copy and paste it and then pass it as your own project, okay? So I have created here a simple circuit. So as you guys can see, I have here my battery. Oops. Okay, I have here my battery. And I have here the connection coming from the positive and then going to the resistor. And then we'll go to my LED going back to its negative or the ground. Okay. From here, actually this was shuffled a while ago, like it's like that. Okay. So the same will happen on the Eagle CAD. So if you have a lot of wirings, that's time that routing this one comes in super difficult. So I guess when it comes to checking whether the connection is correct or no, depends on your schematic. Okay, like this one. So most of our components has a polarity wherein positive should be connected to positive and then negative should be connected to negative. Okay. So like maybe capacitors or polarized capacitors, maybe for potentiometers because they have certain pins. So in that case, you really have to look for the data sheet of that component. Like what is this pin? What is the second pin? What is the third pin? What is the fourth pin? And so on and so forth. Okay. Your previous project. From the soft design, Mr. Claveria. Yeah, you can do that one. It's a really good project. Okay, so I have a direct message here. It display both the breadboard and schematic launcher. For the lab number 5, lab number 5, I only need the this one, the FreeSync layout. I didn't said about schematic diagram. But for the others, we have included the schematic diagram. Well, congrats. Then you are now already done with our module, lab number 6, because that's the one that I will let you guys do for the lab number 6. Okay, I need the schematic diagram of your fritzing layout or of your breadboard project layout. All right. What else? What are the other questions? Yeah, no problem, Mr. Claveria. So it's better. Okay. So actually, the more complicated the project, the better. However, just make sure that the connection of the components are correct. Okay, that's very important. So that's why having a virtual breadboard, virtual battery, and virtual connections is not enough. Okay? You should really try it with yourself. Meron nga tayong kasabihan, experience is the best teacher. Okay? It's not just enough that you're able to see it, you were able to touch it, but you have to experience it on your own, right? And how it works, how to do it properly, blah blah blah. Okay, so any other questions so far? Well, supposedly this will be part of our discussion anyway. We have already done the breadboard part and then the schematic part. All right, so any other concerns?
None, sir.
And one more thing, Miss Dulay Santiago, am I right?
Yes, sir.
When it comes to connection, just make sure that the maximum voltage, let's say, of that component will not be overloaded. Okay, like for example, it can only accommodate, let's say, up to 5 volts only or 12 volts. So do not put a supply wherein it's directly connected to 24 volts supply. So that's a thumb rule, I guess, wherein you must know the limitations of your components to avoid, having a burning or getting failed components or burned components rather. Okay.
Okay,
So yeah,
sir.
polarity and then the uh, limit of the voltage that it can accept. All right. So are we clear with that one, Ms. Dulay, or do you have any other question?
Clear, sir.
All right, so just show, if ever you want me to check a certain schematic diagrams, just message me. Okay, so feel free to ask me anytime or consult me anytime. So all of you guys can consult me anytime if you want me to check your work before, submitting it as your final project, for example. Okay. All right, so let us now start with our discussion, short discussion. So just a definition of schematics. So what are schematics? Okay, so we have, or I have prepared 3 definitions here. All of them are correct. So the first one is, it is a structural or procedural diagram. So this one came from one website. And then there is another source wherein it came from Wikipedia. So schematic or schematic diagram is a representation of elements. Okay, so this one is much more general. So I like the definition of this one. So that's why I included the definition of Wikipedia. So representation of elements. So elements could represent anything. Could be a schematic of abstract, and could be graphic symbols, okay, or rather than realistic pictures. So that's difference between your project lab number 5 from your right here, the lab number 6. So the last one will be the real picture or the real representation, but in schematic diagram, it will be represented by symbols or by a certain, let's say, drawing, okay? Like for resistors, it's a zigzag drawing, okay? And then the last one is, it is used to graphically represent what a circuit is doing and how it is functioning, all right? So yeah, very, very straightforward. Structural, procedural diagram, or representation of elements, right? And here are some of the basic electronic circuit symbols, wherein it is already in the form of a schematic form. Okay? It is now ready to be copied as your schematic layout or schematic diagram layout. So we have here a representation of a lamp. We have here a wall light, light globe, switch, locking switch, and so on and so forth. So there's a lot. Okay. So there are other components which is not included in here. Okay. But if ever you'll be needing one, so we have the internet for you to search what is the schematic symbol of that one, or you can just look for the real components on the FritzSync. Okay. So if it's available in here, then just check that one. Let's say, for example, a rotary potentiometer. Okay. And then you can always go to schematic. So what does rotary potentiometer looks like? So like this, it has 3 pins. Okay. So in that way, you will not find a symbol or what is a symbol of that specific component. Okay. So you can always open your FritzSync app, okay, to check what is the schematic symbol of that component. All right. And yeah, so we have a speaker, antenna balance, transformer, resistor, etc., etc. Okay. And then here are most for the common of the common of the common of symbols. Of course, we have here diode, capacitor, inductor, resistor, DC voltages, AC voltages. So I know that you guys already know the left side components. And then for the right side components, just in case you have this program in your, let's say, project wherein you'll be needing AND gate. So here are their symbols. The AND gate, NAND gate, OR gate, NOR gate, XOR gate, and then inverter NAND gate. So this one is considered as IC, wherein we perform a certain program, okay, like OR, NAND, etc., etc. All right. And for the voltage source, so of course we have a lot of representation for voltage source. So for DC, we have this one. So positive and negative voltage only, depending on the polarity. And then we have here AC. So it's a fluctuating sine wave. And then we have here a like a battery representation, but this one is similar with the voltage source of this one. Okay, so the longer one is your positive, and then the shorter horizontal line is a negative. Okay, then we have here a very simple schematic wherein you always have this kind of polarity. So we call this one, or yeah, we call this one conventional flow of current. Okay, so we have two flow of current. Could be, what is the other one? Uh, elect electron flow of current. The other one is conventional. So the electron is counterclockwise. It's flowing from bottom going to top. So it's counterclockwise. The conventional is positive, or it's clockwise. Okay, from left to right. All right, so that's it for the voltage source. So I guess you guys already know this one. Very simple. And then we have here the addition of subtraction or subtraction of voltage. So this is one thing that you guys need to be take note when it comes to let's say putting the a lot of independent voltage source. Let's say we have here a 10-volt battery, and then we have here another 5-volt battery. So the reading of this one will be 15 volts, because we have this polarity. So positive to positive, negative to negative. Okay. And then if you're going to do this one, the other way around, wherein we have positive to negative and then negative to positive, well, of course, they will be deductive with each other. So whichever one is greater, and that will be the one that it will dominate the sign of your, or the let's say, ano tawag dito? The polarity of your voltage source. So if the negative is higher, then we're now having a negative flow of voltage. If the positive is higher, then we now have uh, a positive flow of voltage, right? So that's why in here, 10 plus minus 5 is equal to 5 volts, all right? And in here, we could also have a current source, okay, just to improve the flow of current. So it's not always the voltage source. So sometimes you could also have a current source wherein you can improve the current source to this, let's say, output. So just to do that one, okay, you have to connect them in parallel connection. Okay, so in that case, 5 amps here and then another 5 amps here. So they will be added at this point, and then you will get 10 amperes. All right. So that's how you increase the current on a certain circuit. And here are just some of the series full connection, just in case you want to solve the output at of this point. Let's say, what is the output at this point? What is the output of the voltage source of this point? Etc. etc. Okay. So we have here, or the series, of course, for the current. Okay. So whatever is the I total is equal with the I1, or the first component that is going to pass through, I2 if ever you have second component, up to the end. Okay, so all of them are the same when it comes to current. Okay, and then for the resistance, of course, for you to be able to get the R total, just add all of the resistance on that circuit. Okay, and then you'll be able to get the R total. And then for the voltage, so this one is in parallel. Okay, so whatever is your voltage source, okay, it is the same with the branches that it will flow with. Say you have two branches or two nodes, then they are the same. So E total is equal to E1, E2, E3, and so on and so forth. And then for the resistance, so if you have more than three resistance, then you have to use this formula. If you have two resistance only, or two resistors, then you can use this formula. Okay. And for the current, so for you to be able to get the I total, so we have to add all the individual nodes or junction. So I1, I2, I3, and so on and so forth for you to get the I total. All right. So yeah, this is just a recall, just in case you forget how to, compute again. And then we have here normally open versus normally closed. So for the normally open, so from the word open, there is no flow of current. Okay, so the connection between two wires is not connected since it's open. So of course we have here 0 as a representation. Then of course 0 volts, it's false, it's off, or the current is not flowing. So we have a lot of representations when it comes to normally open. And then the normally closed is just, the opposite of the normally open. So this one is represented by 1 in binary, so it's turned on. There is a voltage flowing, 5 volts. It is true, it is on, and then the current is flowing. Okay, and then let me just share to you guys a sample switch. Okay, wherein we have here, normally a switch has 3 pins. Okay, so if you're going to connect the pin right here and then the pin on the common pin, okay, so this one is normally open. However, if you're going to connect the other one on the normally closed pin and then the common pin, that is normally closed. All right, and then this is the push button, which is to trigger this one to connect or to make this normally open be connected on those 3 wires. Okay, so for us to have a clearer say viewing of this one, we have here the normally open switch, wherein of course you have to connect the wire here and then the wire here. Okay, so initially, of course, since it's open, then there is no flow of currents, it's 0. But once you press this push button, okay, or you hold this one, it will connect this wire on this common pin. So common pin is like our ground, okay, wherein it will give you 1, okay, wherein it is now connected with the other wire. And then for the normally closed switch, so the pin or the wire is connected in the common pin, which is ground. So it's always one wire is always on that wire because that is our ground, and then the other one is connected on the normally closed pin. So initially, even though you're not pushing this one, okay, it's on the on state, and then once you pull this one, and that's the time that it will disconnect those two. Okay, so it will make it close. Okay, so normally open is normally off. Normally closed is normally connected or normally turned on. All right, and we have here a sample schematic diagram, which the one that I showed you a while ago. We have the battery, resistor, and an LED, and then we have here a switch. So this one is normally open, so you have to close the switch for you to have a flow of current. Okay, and then another diagram wherein we have here the battery, we have here the switch, and then transformer, and then we have here a relay of 5 volts, and then we have here a voltage source of 50 hertz. So once this one is connected, then this relay will work as your main source of voltage or main voltage source to power up this lamp. All right. So basically, those are just the difference when it comes to LED. Since this one is just an indicator, this one is to light, to light up something. Okay, of course, you'll be needing a higher voltage source. All right, so yeah, that's it for the module number 4. The part wherein you want to learn the step by step is, where did I put that? Okay, so if you want to learn more other symbols, then you can visit these websites. Okay, so this guy is very good when it comes to explaining individual components. Okay, so make sure to visit this one. So he even has a schematic diagram from scratch, and then he'll do that on actual, okay, using a breadboard. Okay, until he's done, and then of course he'll make that one work. So this one is a 555 timer. Okay, and the other one is so this one where normally open and normally close came from. Where is that one? I guess this one. All right, so this one is similar with the other one. I guess I wasn't able to include the other website where I think it is a crash course when it comes to reading a schematic diagram. So I'll just add that one later on. So make sure to check the overview. okay, to check the 1 hour video. Okay, that's a very good video for you to learn this step by step on how to read a schematic diagram. Okay, so we'll teach everything in there. And yeah, so that's it for the module 4. For the lab number 6, yeah. For the lab number 6, to create a schematic diagram of your lab number 5. Okay, so whatever is your project, so I need to see the schematic diagram of that one. So you can use any tool or application that is available on the internet right now. Okay. Okay. And yeah, that's it for the module 4. So any questions so far?
None, sir.
None,
None,
sir.
sir.
Sure.
None, sir.
Okay, so this is my only friendly advice. So I encourage you guys to buy your own breadboard. Yeah, it's uh, not part of the budget, but this will help you in the future, especially if you want to create some simple projects, okay, like real projects. Then you might want to start with breadboard and then start with AAA batteries, 5 volt supply of battery, just to light up an LED for you to be able to appreciate, simple things when it comes to creating a simple project. Okay, and then you can start with LED and then having a potentiometer, having a blinking LED, having a servo motor wherein you can control that by having a switch, etc. etc. Who knows? You guys might be able to create a project, okay, that our society will be needing, okay, in the future. All right. So yeah, that's it for the module 4. So thank you guys for coming, and see you guys after the midterm exam. Okay, so this will be our last meeting. So the following meetings will be your free time to finish all the laboratories and then do an advanced study with the Eagle Gun, right?
Midterms next week, sir.
Yes, sir.
Ano yun?
Midterms next week.
Yeah, midterm next week, 18, 19, and 20, I guess. March 18, 19, and 20, if I'm not mistaken.
Okay, sige.
All
Sige,
right.
sir.
Okay, then. So, goodbye, and see you guys when we meet again after midterm. Okay.
Sige, bye, sir.
Goodbye.
Goodbye.
Thank you,
Sir.
sir.
Have
Bye,
have
sir.
lunch.
Bye,
Bye,
sir.
sir.
Goodbye. Thank you for
Bye,
coming.
sir.
Thank you, sir. Bye.
Bye.
Bye, sir.
Goodbye.